Okay. Hey, Aaron. Good evening, everybody. I hope this is not like the 15th time we have audio problems at the start. Before we kick off with our co-host for tonight, I have an experience to share. I was in the car this evening, went to a gas station, came back, and for some reason my brakes no longer worked. So in relation to the car hacking of last weekend, thought about was there something done to this compass somehow? There was not. So it must be something mechanic. So I need to go to the garage. Fortunately, I was able to stop. So I had to like push my brake with 2 feet to make the car stop. But Ian said it wasn't you. What was you, by the way, is the thing you see on the top. So let me switch to camera view. I got a package today from Ian, and this is actually the mascot. Sorry, Ian, forgot the name again. Maybe you can put it in the chat. And it stated that it had Christmas ornaments. So I thought this is like a tax evasion thing, but in fact it had a Christmas ornament. So let me show this one on the other one. So this is not the webcam view, but the dashcam view. So this was the Begrinio. Mintinet.com 2020. So I just came home, so I did not have time to either get a micro USB or a CR 2030. So we'll try to do that during the stream. But in this stream, we have someone special. We have Pruts on Twitter. His name is Reinier, and we already had contact through our mutual hackerspace. And he did some cool stuff. Actually, he already featured in the stream. He was there. Oh, lots of reverb. Okay. Let me see. What did I do? Oh, so this is in fact the 15th time it went wrong. I put on my. I should hide those. Okay. This was my GoPro, which was recording my microphone as well. So. Thank you, Arun. Reinier already featured in earlier streams. He was in a lot of streams watching, but at one time, Boss Sebastius was designing his thing, and Reinier thought, I can do this much better. So he picked up his own gear, started creating exactly this one. And before the end of the stream, he had even a better model than we featured at the time. But it's fixed. Thanks, Ian, for confirming. Really value that. Reinier, could you introduce yourself?
Sure.
Need to go a little less on the audio. It's quite hard.
Do I need to be quieter?
Yeah, maybe I can tune a little bit. Okay.
Try again.
Might be mine. Okay. So how is it for the people in the stream? Is the audio for Reinier okay? Or is it like on my side? Yeah, just start, Reinier.
Okay. Well, my name is Reinier. My nickname is Wuts, PWUTS on Twitter, Twitch, whatever. um, I have been kind of lured into the hacker scene by Sebastius about 5 years ago, and well, I haven't had any intention of leaving since. I learned a lot about hardware hacking as well as designing, um, and also 3D design, inspired by, well, the abundance of 3D printers on the scene. Um, I attended my first hacker event in 2017, which was SHA 2017. That was quite an experience. um, since I have attended, well, not all but most Dutch hacker events, so ETH Zero and Hacker Hotel, and they're a lot of fun every time. And at, I think, ETH Zero, I met Yillis uh, last no, wait, last autumn, last year.
Yeah.
Um, and you know, uh, he's not really a person you forget. So, and then at some point, I ended up doing a parallel stream with some 3D design stuff, and here we are.
Yeah.
Today we're going to continue that.
Yeah, that's like we already had some time on Discord, I believe, where you showed me some really cool stuff. Can you show what you actually made, because you're already tearing it apart, and can you explain for the people that did not watch the earlier stream?
In the earlier stream, it was a small demonstration about 3D design. So, okay, we have an object, in this case in M5 Atom, not sure where I left it. And then, well, how do you turn an object into a computer model? And
we did it the easy way. We just downloaded a 3D model and turned that into the device itself, I believe. And you made it entirely from scratch.
Yeah, I thought it was a nice challenge, and then in the end, I thought, I've come this far, I might as well finish it. So it's not that many steps, if I may say so, but the art is in dissecting a model into small steps to make nothing into a 3D model. And you'll see in a second that how such a process works. And in this case, we're going to design something from scratch, but here it was also a lot of measuring and making sure everything's accurate and looks accurate also when you render it. And then in the end, there's a lot of different components. And you turn all those components, the growth connector was a model in itself. And then you turn all those components into an assembly, which is basically, okay, this part connects to this part. They may have or may not have freedom of movement in certain directions or dimensions. And by specifying those, you can make a model which can be pulled apart like this, and then put back together neatly.
Yeah, it's like so realistic.
Yeah, thanks. That was kind of the aim.
Yeah, completed. Before we start on like 3D stuff, you do some other stuff as well, right? You showed me a website, and you showed me like something you did before, and I was already actually by Crazy helped me start in domotics, and I still had to do a lot of stuff. So I had to still install my door contacts, and I had to contact my smart meter to it. And you actually designed something for that.
Yeah, I did. I don't really have a specific project page for it. Well, I do, but it's not up to date. But the idea was to create a device which you can connect to a smart meter like this. This is an electricity meter, and this was, well, my prototype for, I think, 4 months or so. And then it turned into a PCB, which it's a simple piece of hardware, but it was my first PCB, so I put quite some work into it. And it's basically a hardware interface between a microcontroller, in this case an ESP32, which runs on 3.3 volts, so it needs some level conversion as well, to the serial interface of the meter, which can also supply 5 volts, which with a capacitor on it allows to, well, this was a kind of bodged capacitor, but with a 230 microfarad capacitor on here, it allows you to power the whole device from the meter itself, which is quite convenient because you don't need external power supply.
Yeah, that's usually the case. Like in your cabinet, where your meter is stored, you have limited power, although the power comes in there.
Indeed. And then after the hardware interface was finished, which is, I think, now half a year ago or something, probably more, I continued working on the software side of things. And I have written some firmware to parse the telegrams, verify them if possible, and push them over MQTT to whatever you want. Also in influx format, so you can just pour it into an InfluxDB.
Yeah.
And then
make it Grafana.
Yes, also, if I can find that. The last thing I've been working on for this was a Docker Compose configuration, which allows you to just download the repository and then run the compose file, and it will start all the necessary containers for you, including InfluxDB, Mosquito for MQTT brokering, Telegraph for transferring the data from MQTT to InfluxDB, and then Grafana to render it all with some prefab dashboards, which I use myself. And it gives, these graphs. This is for daily usage. So this is real-time current usage, and this is over a period of 3, 6, 12 hours. And this is for the longer term. I think I can show this.
Actually, Sebastian is in the stream as well now, so he's expecting us for the Hackaday Remoticon this weekend. So there was something happening to me, as I totally forgot that this midnight I have a hardware hacking workshop featuring 274 participants. So don't know exactly. Yeah, you're jumping back and forth. I can imagine. Like I will do the same.
Okay.
It looks very cool. And this is all Docker, right?
Yeah. In this case, this is still the bodged version running on my PPS, but you get the exact same thing by running the this Docker configuration. I was kind of inspired by Sebastian's complaining it was all impossible to set up and very hard, and it all broke down. And then I thought, maybe I can solve this a little bit, and I came up with this.
That's how the best solutions start, by people complaining. Yeah, I really like it. I have similar feelings as Sebas, as I was setting it up, and thought, well, why? I'm not going to do an InfluxDB. I want to do like MariaDB and set it up. And was on one of the previous streams, and it turned out that it had like this issues with UTC and CET, where it would all work if you were like in the overview screen, but as soon as you started zooming into data, it would like jump back to the old data format and no longer show anything. So you had to like move 2 hours in the future or in the past to make it work.
Yeah, in this case, last thing I want to show you to not get too much.
No, please do.
I started this project for fun, but it turned out to be a real energy saver. In the first weeks of us using it, our gas usage mainly went down by 50-60%.
How so?
Which is just because people can see their own impact on the consumption. And now you can also see that as it's getting colder outside, the gas usage is going up. And
people are wearing sweaters to not impact any graphs.
Well, we do that, but you know, and not freezing house is also nice.
That's right.
You can also see the approximate CO2 emissions from the gas usage, which is, you know, not exact, but it's an indication.
The CO2 from the gas.
Yeah. Assuming an average Dutch gas mixture, I could calculate the energy equivalent and also the CO2 emission per liter burned.
So how many trees that you have to plant to be neutral or not?
Pretty much, yeah.
Cool. Yeah, I noticed that it works the same for us as well. So I always fought against a smart meter as an intrusive device where I send my data to a provider and it's centralized, so if they don't have their infrastructure in order, it would impact me. And then I had this domotics project where I made a mistake in programming and ignited all my smoke detectors in the middle of the night, and my wife has these terrible migraines and she was not happy. And as I was using the smoke detector as well as an alarm system, they were not on an easy reachable spot. So that was the moment that I had to give in and buy the smart meter. And now you see what you do, and you actually tend to gamify it and save money, and so that's actually cool. And I think it's even cooler if you host it yourself and if you build it yourself using MQTT, using your own gadgets, and like crazy show this ID with attaching Dallas temperature sensors to the pipes of the central heating to see how many intake and how many outtake you have, and when you're using the warm water, and people were already telling me you need the humidify sensor in the bathroom to see if someone is showering, and it's like getting bigger and bigger and bigger. Yeah, cool. So how did you learn this? Is this just tampering, or is this like something that you learned during your education?
Well, I most of it was trial and error.
Yeah. Just go.
You know, I had been introduced to things like Grafana, and then at first you're just like you Google something and you copy a dashboard and tinker a bit with it.
Yeah.
And then you at some point you learn how all the buttons work, and you can go a bit deeper and connect some devices, and it also in this case helped that I worked together with Jurt on the ESP Wi-Fi settings library for Arduino related projects with Wi-Fi, because it really makes things easier in this case with configuring the microcontroller to connect to the right Wi-Fi network and send the data to the right MQTT topic server. You can switch certain options on and off, and that takes a bit of stuff you need to code away from yourself.
Yeah.
And puts it in a library.
Yeah.
And then it's a lot of code to which I spent actually most of the time on
Configuring.
to get a telegram and then parse it, but also verify it, because the telegrams containing the data from your meter, they contain a CRC verification.
Oh, cool.
Which means that theoretically you can verify the content of your telegram and see if it's correctly come through. Because in the beginning, as you may probably have guessed, this setup is not very fault tolerant. I had a lot of garbage data coming through, and the verification helped a lot with filtering that out. But unfortunately, some early versions of DSMR, which is the standard which specifies the serial protocol, does not contain those verification tags. So those are a bit more wacky, but and then once the verification was working, it's just iterating and working long term and finding issues.
And like you're debugging multiple things. Station was asking a question if you could use the soil moisture sensors, like the thing to see if you need to water a plant, as a humidity sensor, but Crazy already replied to have the BME or the DHT. I have the same thing with the breadboards. I really love breadboards, but over time wear and tear, having different Dupont cables, extending pads, turning them into a capacitor, is really introducing other stuff. And as soon as you make it definite by either using an experimental print or designing a circuit board, like all these problems vanish. So
that was a really big thing indeed. I in the beginning I thought this is never going to work reliably because of the amount of errors I was getting. But just turning it into a PCB helped so much.
Very cool. Today I did reflow on stencils with SMD and really cool stuff. I see a lot of unicorns around me now, inhaling all the fumes. But it was fun learning a few new tricks.
Nice.
And
did it work?
It did work. So actually, if you look on my Twitter page, there's a post that I made three posts ago. Colleagues have started a CTF, so this one, and if you win it, this is what you win. So this is a shitty add-on connector, and this is like the logo of the team. So if you go here and you look at U1, there's that's the other one. So this one, actually, if you do a chip of that chip, it will state "Hi, Yillis," as in "Surprise, we got you." So this is like an extra challenge on the challenge, but spoiling it a little bit. What they did is create like an ornament for in the Christmas tree that you can address using a web browser and a captive portal. So you can turn it into any ornament that you want with any animation. And you could also turn it into a CTF where you need to do easy challenges, harder challenges, and even do soldering on them. So one of the guys doing the hardware is Max, and I want to ask if he could like join the batch team Telegram as well, because I think he has a lot of value to bring.
If he wants to, he's welcome to join the group.
Yeah.
Of course.
Cool. So it was a lot of fun. And another friend gave me some older badges, so I have like a bag of badges that I didn't have before from events that I didn't go to, but still epic to look at the different ones. Tonight the idea was to go and I see something else. Never tried the raindrop sensor. Actually, I was invited by TU Delft for an Arduino workshop 5-6 years ago, and their best design was actually someone using a photo frame with a piezo element on top of it that would count like the ticks on the water. So that is like a design that could work in poorer countries, that is working really well instead of having buckets censoring and measuring the amount of raindrops.
Wow, that's really smart actually.
Yeah. So you have a large surface, and the large surface amplifies the sound on the piezo that acts like a microphone instead of a speaker. Was the winning design. So that was actually my first introduction into Arduino, by the way. Must be 7 or 8 years ago. So we designed this board where these atoms were on, and actually this was just an idea that I had, inspired by Joseph. Joseph is Jelle's boyfriend, and he created a war driver for what's the name of the Wiggle. So it is collecting access points and GPS locations to have like a mapping of all the access points in the vicinity, so that you are able to triangulate or determine your position by having an access point name or SSID. So that's how this idea came to mind. So I thought, if I have one, Joseph at least needs another one. And then M5 Stack donated me a drone, and I don't know much about drones. I don't know much about math as well. So it stopped for me when like letters were introduced. So I was able to spin the motors, but there was like quite a complex process on it, and did not make much sense to me. And Danny was already creating his own drones and flying with his own design drones. So I gave him the drone to work on it. He was already working on it, making it fly, and he will feature on any of the next streams. The next one is actually Tom Clement, Mr. Campzone.
Hey.
And but there's already 4 or 5 people that have this particular device. So some have the ones without lights, or a few with lights, so you can make any combination that you want. So there's like atoms with audio, there's atoms with a button, there's atoms with a matrix in there. But this is very cool. But yeah, it would be totally epic to have like some sort of a casing for it in 3D. And I saw you build the stuff, and it really looked fancy. So I also saw the casing that people designed for the ChemZone 2020 batch that really looked fancy.
That was really cool.
Yeah, and it would like fit into each other, and you could take out the screws, and it would just work by having. You have it somewhere. This is the original device.
Let's see if I can find it.
Yeah. Let me grab the M5 stack matrix squared from my desk somewhere. Be right back while you search for the and explain about this one. Yeah, thanks.
Yeah, this was a case by Kartoffel for the CampZone 2020 badge. Of course, the CampZone badge for this year was it was a lot about sound. Of course, that was not the only cool thing about it, but one of the popular uses for it was to be a soundboard, and this housing kind of well, I actually I'm not sure if this part, like the panel at the back, is original or not. But it's, of course, it hooks into the audio theme. This badge also has a really cool web interface. I'm actually not sure anywhere where on the web it is. But this was one of the first badges, I think, to use web USB.
Yeah, epic.
Which basically gives a web interface via USB for the device, which makes it, of course, very user-friendly. You can just throw files on it and adjust settings in your browser, which connects directly to the device, which is, well, for especially for beginner users, very cool, because it's really easy to get started. And spoiler, we are working to / hoping to get this in the MCH 2021 badge as well. Well, I mean, not exactly, but the same kind of web interface.
Yeah, I never knew this was possible by using the the STM32.
Yeah, because the let me see, can I have this full screen? Yeah, the two circles here are small speakers. Not sure if they are piezo speakers, but nevertheless speakers. So it looks like this panel is actually originally from the attached to the badge. So then it's the frame that is from this 3D model, and the rest is original from the badge.
Yeah.
But it's it's not purely geometric in the sense that it's square and rectangular.
No, there's an angle in there as well.
Yeah, it has been made to look, well, smooth in a sense.
Yeah.
It has round edges, and it's just aesthetically pleasing, even though it's not a really complicated design.
No, but what really helps is if you look at the buttons itself, and especially if you have like the higher buttons, the buttons itself tend to move a little bit, and you fixate those by having this template on top.
Yeah.
So they will be really firm, and you can use it like for controlling your OBS setup. With all the macros. And what I really liked about this idea over previous batches is like limiting your options. So if you are able to put data on the screen and work with that, then you can say, well, where do I want to put it? What will the color be? Do I need like embossing? And this is just, you have 16 options that can have different color. So you could make it something that would have multiple pages, or have different colors, or make something blink, or so you have to come up with crazy ideas to expand the possibilities. And in my opinion, there were more apps created for this one than for previous batches, but correct me if I'm wrong.
I couldn't say. I
Okay.
don't know the numbers, but I could certainly imagine it being true.
Yeah. Yeah, it's like, yeah, this is so much easier for people to start on. Yeah, you could take an previous design, and that's what I like about the hatchery. Yeah, having a previous design, working on it yourself, making a different version of it, making a different functionality, and you learn how to code by looking at the code of someone else.
Hmm.
I brought my matrix,
Ah, look, there it is.
and I even have like, oh, it's green, and I have a green screen, so that doesn't work. So let's take this other thing. So because it must be kind of hard for you since you don't have one designing it. So
We'll see how it goes.
yeah, I got myself one of these. So the exact to measure stuff that you want to know.
Okay.
So there's a few things that you need to know. As we are using 3.1 amp to power it, they tend to get hot. So there needs to be a way to prevent overheating. Furthermore, the bottom row will have the growth connectors. So there's one growth connector on the entire circuit board, but if you want to connect more, you could even use the bottom row of the devices. Let me show that on the camera. So there's 4-5 connectors.
So are they? I think the growth connectors are not linked together through the PCB, right?
No. The
Okay.
PCB is using a different I2C bus, but you could also connect, and we're using it as an I2C bus. Could also be 2 one-wire buses. So
Okay, right.
have not made up our mind. So we have a setup where we have like 2 buttons controlling another button, so there's some communication back and forth.
Okay. So first things I'm going to do is find out what exactly was the dimensions of these things again.
Would it help if you had the Gerber files from SBOS?
Yeah, or the KiCad files is
Yeah.
fine as well. At least I think I have KiCad on here somewhere.
Sebas, could you help Renier? Busy. Should I?
Yeah, you should give me the PCB files, which I actually already asked for like a month ago.
Love you, Sebas.
Please give files.
Yeah. Miss you.
Love you.
Yeah. Yeah, he must be crazy as well, like doing the ETH0 and then attending the Remoticon and hosting stuff on Remoticon, and it's all different time zones, and now even joining as well. I was not expecting Sebas to join. Yeah, you can actually join. We used your Zoom invite code, so if you want, you can.
Sure.
Come on in. So I got some. These were sort of sponsored. So I paid a part and they paid the most part, the atoms, and I bought some stuff as well. So I got myself this one, which is a setup where you have a GPS device and an atom the click atom, but you could just remove it and turn this into like a voice activated. So need to.
Is that a module which you can just put an M5 something on?
Yeah, absolutely.
Ah.
And they even have like a version that's a prototype. I can send you the link, Sebas. I will do. Copy.
He has joined.
Okay, cool. And I probably have to admit him.
Oh, hello.
Hey,
Hi.
knappe man. So how is it possible that you even have time to join this? You must be a very busy man right now.
well, the currently there's the circuit sculpture workshop on Hackaday, and it is interesting, but I got the gist of what they're doing, and I'm ready to do other stuff.
I was supposed to join that one, the circuit sculpture.
But they did do it in a cool format. They have the remo.co setup for it, so so they're doing a central presentation, and then all the workshop attendees can get their own virtual table.
Yeah.
Have a 6-person call, and then the host can just join in on that specific call. It's a wonderful piece of engineering, that the Remoco software. And they're doing a Hackaday hangout later tonight at 11 our time.
Okay.
If you have a workshop tonight, so
No,
you're already booked.
The workshop is at 4:30, so I have some time in between.
You mean you have a chance to get some sleep somewhere? No.
Yeah. Actually, I will be attending the PH Days, the Positive Hack Days, which is a 7 days CTF where you hack like smart cities, cars, and other cool stuff. So
cool, sounds good.
But it is all in Russian, so I have to do a lot of Google Translate to make it work. But I have some bilingual colleagues in Moscow. Yeah.
Okay, so the good news is I found the KiCad files.
Cool.
The bad news is I have no idea yet how to add that to a GitHub repository, so give me a few seconds.
Yeah, or you zip it and send it to
we can do that.
Yeah, or you can also ship me a USB stick if that's more convenient.
I only have broken USB sticks at the moment.
Oh, I have a lot of broken USB sticks. I actually bought every USB stick available on Amazon under €5. And
that's a good thing.
And actually I use those to tear the stuff apart. So let me show a microscope for you.
I had a lot of fun a few days ago repairing someone's
I still need
USB
to
thing.
It is recorded, right? Hopefully.
I have, but I need to rip it from Twitch and put it on YouTube.
Oh yeah, but I can watch it on Twitch as well.
But the gist of it is swapping a controller sometimes works.
Okay.
So Puts, do you want it in your email or in WhatsApp or in Telegram? Is Telegram okay? I can just chuck it in Telegram. Fine. Cool. Puts.
Good to hear your voice, Sebas.
And here you go. You have
I
a zip
question.
file. Just one.
No. Why does the flip dot behind you ever move?
I normally don't run it. I can switch it on if you like. Normally don't run it because there are still some bugs to be worked out, and I'm fearful that one of the bugs will cause a condition which will burn and cause smoke. But here you go.
Whoa.
And it's also pretty loud.
Yeah, I got that from your sound.
But yes, it moves.
So
And
is it remote controlled?
it's currently just on one of those IKEA thread-free relays, so I can just switch it on and off, and it just does Game of Life. But it has an ESP32. at a previous point, I just had a smaller panel in a frame where I could play Snake and other stuff on it. So I'm hoping to get back to that, but not at the moment.
Monochrome pixel flute.
Yeah, maybe. It's probably too slow and boring for Pixel Flute.
A batch firmware.
Yeah. Yes, I had that working, but it was slower than the C firmware I made, or the C++ firmware. So, yeah.
How many,
okay, well,
how many pixels are there?
It's, let me think, 32 high, I think, and I think it's 96. No, yeah, I think it's 32 high and then 96 wide. I'm not entirely sure.
Cool.
Yeah, 32 by 96.
Yeah.
But yes, it ran on batch firmware, but that's too slow because of the Python stuff.
Yeah. Cool. Thanks.
So, and you are doing BGA stuff, and Renier is looking at KiCad files. We have a busy evening here.
Well, I'm currently wondering why your zip file also contains a folder called __ Mac OS X.
That's because it's done on a Mac, my friend.
Why do I have to care about that?
There's an executable in there that you have to run as administrator.
Yeah. Yeah, and then you enter your email password and your PIN code and your credentials from your credit card, please.
Yeah.
Especially don't forget those 3 numbers on the backside.
Yeah.
So, but you're doing BGA stuff already, Yillis?
Actually, I was reflowing batches today. There was a thing where if you started ordering batches with pick and place machines that no longer work at the beginning of the year in China. There was a thing like people not being able to do pick and place. So we had a lot of batches and a lot of components, and that still needed to be assembled. So learn a thing or two.
You're not talking about one of the batch team batches, right?
No.
Because the word batch triggers, and I'm just getting confused. But it's mainly because I'm tired.
It's the one of the batches that was made for the company I work for. Khaled was a colleague of Khaled, Max. He made the batches, the hardware, and he spent a lot of time on building the firmware. So his idea was to get in touch and adapt the batch firmware, the batch team firmware. So have it.
So it's an ESP32 board.
Yeah, it's an ESP32 board, and it is a Christmas tree ornament that can be remote controlled for the people that are not tech savvy, and it will be a CTF board for the people that are tech savvy. And even
that's a clever mix.
Yeah,
I like that.
Yeah, and it even includes soldering for like the pros. And
nice.
I posted the picture on Twitter. So I was not aware of it. I was not busy with it, but they included like a gesture to me. If you desolder a chip, it states "Hi, Yillis."
Yeah, I saw the photo.
Yeah, you won. Yeah.
Boss.
Yes, Renier.
What was your grid size for designing this PCB?
What are you assuming? Grid sizes? Come on, man. Oh, it's a 2 point. The pin headers are just 2.54 millimeter, but the spacing between each atom, I did distribute it, but I didn't set a specific spacing for it. I just went with what looked pretty because we didn't think of doing a case, especially not one in 3D print. What I suggest you do is. What I would do if I would laser cut this is just export this PCB layout to a PDF, import it in Inkscape, and then just use all the lines as cutouts.
Yeah. That sounds awful.
No, it's not awful. It's easy.
Okay.
Depends on if you're at the start of this process or in the end.
It depends on your level of sadism and yes, how far along your craziness goes.
Yeah. Actually, someone cut the cables of the battery pack that was to be installed at the end, and I only had like 1 millimeter spare, so I had to insert like cables with tweezers to make it work. So adding some sadism to the work.
Mm-hmm.
Okay. So it's
have you heard of the glorious tool known as the KiCad measurement tool?
well, a long time ago in the dark ages or something.
Yeah, in your toolbar on the right-hand side, there is a measuring tool, and you, some digital calipers somewhere at the bottom, I think.
Ah, right.
And there's also above the black and yellow crash test dummy logo. There's also a measurement tool, I think, but just try it out.
Okay. Yeah, the point is that it snaps to the grid, and the grid is not aligned with the rest of the lines, so that makes it kind of.
Then at the top of your screen, you can just set another grid.
Nope.
Yes, you can.
Right, this one.
Yes.
So it has a 4 millimeter distance between the M5s. At least that's what I'm measuring.
Yeah, and the trick with designing cases anyway is to have some tolerance in there so stuff can wiggle.
So if you make it 2, then you have some... but you cannot make it to the front because then you won't have like enough heat.
I can't find the grid size which aligns properly, so
it probably isn't.
I'm just going to calculate the dimensions.
But if you set it to a grid size of 0.000000 something, you can just make it work, right?
Such a great idea.
Yeah, that's me being pragmatic.
Okay, so this one is.
Hey Joseph, welcome. I saw you had some cool circuit board coming in for your new war driving thing. Is it working already? I did not have time to read up on it. So on the top it's 6 millimeters. In between it is 4. On the sides it looks like 10. Yeah. And on the bottom.
Well, first I'm going to make a square of. Let me see.
You need the entire size?
I already got it, I think.
130? Not oh. Yeah, 130. Yeah, your PCB works, cool. And still haven't got the package with the stuff right. Like, yeah, for some reason sending stickers over to the UK is there in like a couple of days, and sending a package will take like forever.
Yeah, but the UK mail is not the fastest internationally.
The Royal, yeah.
A Royal UK mail.
Yeah.
Not just UK, Royal UK mail. So there are 24 millimeters squared. And there is, okay, you said there was a 4 millimeter spacing between them?
Yeah.
We are going to make a pattern out of this. if I can find out how to do that. Right. So for this way and for that way, and with a 28, which is the dimensions plus the margin.
Oh, okay, yeah.
Spacing, so that it gives us a grid.
Yeah.
Except I should have added the corner fillets first, so
Yeah.
I'm going to procrastinate that a little bit longer. Because these cute little squares are rounded a bit, so we're going to add sketch fillets to the corners, which is, fillets is just an expensive word for round the corners. The radius is 2.5 millimeters, I believe. Let me check. Yep. At this point, I'm just using my previous model for reference, so I'm trusting I did a good job last time.
Yeah. And you do have an atom at your place.
I do, yeah. I used that to measure everything the last time.
Yeah.
So now it's the right shape. I can do a linear pattern. 4 repetitions for this way.
And you're using on shape. Is that like paid, or is it like subscription, or free? Students?
I have a student subscription, which is just enterprise with an education symbol here.
Okay.
There is a free plan which has as its only limitation, as far as I know, that you cannot have private projects. So
Okay.
Every document you make can be accessed by the URL, and anyone can access it. They cannot edit if you don't allow it, but they can access it.
Yeah.
So I'm not sure what the paid licenses cost, but it's not really my concern.
No, I understand. But don't, you can use it like for simple stuff, but don't design your vault in it.
No, I wouldn't recommend that. Not unless you have a paid license. But then again, if you're designing a vault, you can probably afford it.
Yeah.
Yeah, and it's sad that we are getting good open source and free circuit board design software. 3D CAD is yet another completely different ballpark to play in. I have not found any open source software yet that can do stuff at the level of Onshape or Fusion or any boring Windows tool. Sadly.
Yeah. Too bad.
Oh well, it's getting there, but it's just not done. It's,
yeah, and I don't mind paying for stuff, but like if you need another subscription for stuff that will, it's like the same thing with you used to have like just Netflix, and then it was like HBO, and then it was Amazon Prime, and now it's Disney, and it adds up like to something that's not funny anymore.
Yeah, that, but also besides the subscription model, which makes sense sometimes, it doesn't always. The main thing for me is I want to share my projects, and I want to be able to access my work 10 years from now when the software company has moved on. And that's something with open source software, you can just keep an older version of it and just keep working with that.
Yeah. I'm going to pin Ranier's video.
Yeah,
so,
sure.
He is.
Yeah. For anyone.
He should be in focus.
Yeah.
I have. Okay. Wait. Let me move myself out of the way. It's not cheap.
Okay.
But then it's a web-based WebGL, very good working as far as I can tell, program. And alternatives are like Fusion 360 or SolidWorks.
Yeah.
Also, I'm not sure what those cost either. But if you're a professional working in the field of 3D CAD,
Yeah.
It may just be worthwhile. And
it's actually cheap for professional software. For enterprise level stuff, yeah, this is what they pay.
So I'm going to move myself out of the way again because I'm blocking my view. Now I'm going to do a trick. Well, it's not really complicated, but still important. I want this to be centered, and then of course you can say, okay, I want to center the grid and I want to center the square, and you center them along a common axis and make sure they are both centered with respect to each other that way. You can also use construction lines, which I'm going to do.
So these are not grouped, or are they?
The grid of squares is grouped, but other than that, no, they're not grouped. It's just you can see I can move this around.
Okay.
And now I'm going to work to fix that by adding constraints and construction lines and dimensions and stuff like that.
Okay.
Because this construction line is not a line that divides two parts of a surface, but it is a line which you can assign dimensions to. And in this case, I'm going to add a construction line on the other side as well. So, and then I can just say, okay, these two need to be equal.
Oh, okay.
And that centers the grid of squares within
these boundaries.
PCB. And I've also, according to what you said, fixed this dimension to 6 millimeters.
Okay.
I mean, yeah, I could measure it in here as well. Let's see if that works.
So to the side it's 10, and to the top it is 6. Yeah.
Okay. So to the side, let's see. Well, it comes to 10.95 millimeters. So
yeah, it must be me mismeasuring.
Yeah, it may also be that the PCB lines are not exactly the size of the M5.
Well,
it doesn't come that close. So
on one side they are over it, and on one side they are within.
Okay. So,
sorry, Rainier, Yillis.
Yes.
Do not trust the symbols I drew on that PCB. The pins are aligned, but the blue lines are rough estimates.
Yeah.
Okay. Let's see what I want to know what the radius of this corner is. It was 6 millimeters.
So what is a good way to measure the radius of a corner?
Usually I just do it freehand, so put the caliper on the, well, is there something I can demonstrate with? You basically put the caliper right here at the point between the straight line and the start of the curve.
Yeah.
And then I measure from this edge to that point.
Yeah.
And then round to the nearest logical number.
Yeah.
Often that gives a good estimate or good measurement.
Yeah.
So like if you get 2.45, make it 2.5, and it's probably correct.
Yeah.
Yeah. There is also tools available to it's probably called a fillet gauge or something like that.
Okay.
You can just buy them. I'll have a look, and if I find any, put a link in the chat.
Cool. Thanks.
Nice.
Nice.
So I've added some more fillets for the corners of the PCB.
Yeah.
Now on the bottom, actually this is not really that relevant yet. But there are screw holes in the corners of the PCB.
Yeah.
and there's also this USB-C connector and the Grove connector.
Correct.
So this is, I would say, the point where I would start to think about, okay, what do I want the housing to
look
like, or what kind of housing should it be? Is it just a bare frame? Is it a full enclosure? Does it need any extra space or holes or whatever? In this case, these M5 atoms are going to dissipate, what was it, 15 watts together? So something like that.
Yeah.
So
more even.
It might need a fan.
Yeah.
And based on that, you can work further into the design.
Yeah.
So let's say we have this part of the design, and we can already make it a small little surface. Mind you, this is probably we're working on, just trying to make an enclosure, which kind of does what is needed. I'm not going to try and make it perfect or very aesthetically epic or something, because that would take, a day or 2 or 3. And we don't have that time.
It's about the design process, how to approach this, how to use the software like from scratch. It's not rehearsed in any way. So.
No. So.
So these have like a millimeter on each side or 2 millimeters on each side. How much spacing do you have around the
spacing around the
atoms?
The atoms. At the moment, it is 0.
Okay.
And actually, it depends kind of on your printer whether that fits or doesn't fit. So I should probably add some.
Yeah.
Make it like 25. The disadvantage of doing this is that if you make if you want well-defined airflow within your case, which I think is a nice thing to try and create.
Yeah.
The bigger the gaps between the atoms, the more it will disturb the airflow or change the way in which the air flows through the case.
Yeah. Understand. However, these are buttons as well, and these are not just buttons that push down. These are buttons that tilt a little bit to the top or to the bottom. So actually the pin header is the mechanism that makes it click.
Wait, really?
Really, yeah.
Wow.
So if maybe I can somehow show it. Let me show it on the... oh, that's not... Oh, that's odd. I can click the screen as well. So actually these are the pin headers. Are you able to see it? No, you're not. So let me zoom it a little bit. So if I push this, let me make a...
Yeah, it's a little bit of a mess, that mechanical bit of it. You're pushing the bottom PCB to the top PCB. I'm gonna see this as my cue to leave. I'm a bit Zoom tired for now, so
yeah.
I need some rest. So guys, good luck, and
thank
see
you
you
for
another
joining,
time.
man.
You're very welcome.
Thanks
Bye
for
bye.
your help.
Nice. See ya.
Bye, boss.
Okay, so I've thought about this for a little bit, and I have a question.
Yeah.
What side of this PCB do you consider the front or back? Like, if you made this into a device, would you want the connectors on the front of the device or the back of the device?
The connectors are on the front of the device.
Okay, and would you like to keep it that way?
So to enclose it and move it to another place.
Well, if this is a device you would like to put on a bench or something, I can imagine that you would want the connectors to be on the back side, so you can just put it there, and there's no cables coming out of to the front or the side, and it's just clean on the front and the sides. And then you can have the USB cable coming out the back and going to the power supply or your computer.
But then you need a USB cable around, or you need to have alter the PCB, or
No. It's that would just mean that I designed the enclosure to be 180 degrees turned with respect to the PCB. So I am considering putting in, for example, a fan.
Yeah.
And if you put a fan in the enclosure, it's probably most practical to put it in the back of the enclosure. But then if you want the connectors in the front, that would mean that I need both here on the front of the PCB and on the back of the PCB some extra space.
Yeah.
But if you think it's okay to...
Actually, I consider the glasses the front.
Yeah, okay, so that makes sense.
The idea is that the bottom will be messy, as it's not entirely clear what we are going to do with the connections. And there's 5 connections on the bottom. Maybe we use one, maybe we need a couple. So it could work standalone, where you just have the M5 stacks and use the ones that are left. That there's 13 channels, and we have 16 devices, so we have 3 left. So we can use 3 masters, or 1 master and 2 other devices. But it could also be we want to add a GSM shield to it to also capture GSM towers, or add a GPS, but we might want to have 2 GPS sensors, as we want to see which one is correct if one is not finding one and the other is. So that's not entirely clear. We haven't even wrote the software for it. It's just some proof of concept stuff. So I expect it to be messy. My idea behind the case is the atoms are quite fragile now. So if you put this in a bag where you carry it around, chances are that the atoms drop off or get detached. So you could even wear it around your neck, as a big badge, or hang it on your passenger side of your car. So you do have a better reception of the devices. So I would consider that it placed in this position, where the connectors are on the bottom side. This is the front side, and you hang something with this part, allowing cables to come out the bottom.
Okay. All right.
So having fans blow air either top to bottom or from the bottom. If you put fans on the bottom, then you have the cables to worry about that are plugged in, and you could put it on the top, and then you have to make it a little bit bigger, but then the benefit is like the bottom is very is quite larger than the top since the connectors are on the bottom, so you have some more space to put in larger fans on the top.
You can also, well, I mean, it's experimental, so we can also
Yeah.
just say,
Make
we
holes.
make holes and
Yeah.
see if the convection is enough to cool it down
Yeah.
to an acceptable level.
Or dim the lights to have it consume less power.
Yeah, sure. So then I wonder. Let me just do something I've wanted to do for a long time. I'm going to import this.
Switch back to your view. Sorry.
Yeah, right.
Okay, cool.
And then see if I can. Yeah. Wait, what? Can I? I'm trying to import the M5 Atom model I created earlier to this document, so I can use it as a
template to see how much space is actually around it.
Exactly.
Does it work?
Good question.
As you look a little bit worried.
Yeah, the problem is I don't see it in the list even.
Okay.
So it's already complaining about versions, and I don't really care about the versions of the file. I just want the M5 Atom matrix I created to be. Oh right, it wants me to create a specific named version of this assembly, which can be referenced also in the future, so that I can edit this document without the assembly in the other document getting messed up.
Yeah.
So I'm just going to make this very epic version 1.
Sounds about right.
And then I might need to reload. Yes. Okay.
There it is.
And then I can add the entire thing and add from my own part studios this.
Oh wow. Yeah.
And then
cool.
I'm not going to take the trouble of aligning them perfectly and adding mating connectors, which would define their spatial relationships.
Yeah.
But I do want to use them to show a little bit how
About
they would
spacing.
be placed.
Yeah.
Because the case is meant to add some strength
Yeah.
to the assembly.
Yeah, I would say put it down. Yeah, tilt it to the top.
Like this.
Yeah.
This would make the reset button unreachable.
Yeah.
I don't know if that's a problem.
No, not going to use the reset button. So if I want to reset, I just take out the bottom power.
Okay.
It's embedded.
That makes it a bit easier.
I'm not able to get to the reset button anyway, because then I would need tweezers or needles to push it. If the entire board is populated.
Right. So I'm actually not sure if I did this correctly, because I'm now seeing that the M5 has some space on the top and bottom, but not on the sides. So I probably messed something up here.
It looks rectangular. Your model.
Yeah, right. I was missing a constraint.
Oh, okay.
Fixed. So now it has space on both sides.
24.
Yeah, it's 24 by 24 and
Yeah, and a bit through because of the growth connector sticking a little bit out.
that's
Or is it like optical?
how much does it stick out? I'm going to get my own M5.
Yeah, 24.40. 50. On the other side, 24.0.
Oh yeah, it's a tiny bit.
Yeah, it's a tiny bit, but that doesn't matter as we are using the top.
Yeah. So
Yeah, Chris said you made it slightly wider a while back. That's what I heard as well when you started off.
yeah, but that's true. But I was thinking it had already created a constraint for it to be square because I had.
Oh, okay. Yeah.
If you draw a rectangle and hold the Alt button,
yeah.
it constrains it to a square.
Yeah.
But if you draw it, you'll see that it does. Oh, it does have. Okay, I have no idea what happened.
Okay.
Anyways,
it is square now.
Mm-hmm.
Okay. Yeah.
So, I think we can assume that you're not going to try and push these through the grid onto the PCB, because you can't even take them out that way. So,
no. So you need some way of taking this apart as well for replacement.
Yeah.
Because currently I do not have over-the-air setup.
I'm going to create a let's see. This is the size of the PCB, so there needs to be some space around PCB in order for it to fit, of course. Yeah. So that's what I'm gonna do now. I can probably just select the edges and tell it to create an offset. Oh wait, it's going in the wrong direction. By making an offset, it just duplicates the line and makes sure the distance between this line and the new line is everywhere exactly the same.
Okay. Yeah.
I want it to be outside. Did you see it replicates the line and follows it around?
Cool.
And then it just becomes a larger version.
Yeah.
And
so you can add strength as well and placeholders.
No. I did. I hit escape and it disappeared.
Undo. I had that with my groceries. I forgot to confirm the shopping list, and turned out that I had to do the entire list again.
Ah. So this gives us some margin. I made it 4 millimeters now. Probably less is also okay, but it shouldn't be too small because then it gets hard. Well, it's not sturdy anymore. So this is probably all you need to make a very basic enclosure.
Yeah.
I can, of course, I can demonstrate that. you start with the bottom surface,
Mm-hmm.
which is just all the surfaces together.
Oh wow.
And this, well, let's make this also 3.5 millimeters. Actually, I'm going to turn the shell thickness into a variable.
Yeah.
To make it easier to adjust. So shell make it 3.5 millimeters. And now I can, here as well as elsewhere, just add shell thickness. Oh wait, I can't because the variable is defined after the sketch. Oops. And it just uses the variable for the value. And I do it here as well, and I adjust the, well, I can probably demo that better at a later point.
Yeah.
And then make another extrude from the same surface, but now just the walls.
Yeah.
And okay, we have the PCB which needs some space. Then the piece, let's say 32 millimeters. This probably needs to be adjusted later, but just for now it's probably okay. Okay, I could probably better name these. So bottom surface. It's not always necessary, but for future reference.
Yeah.
I've hidden the bottom part, and I see it's not attached to the part I already had. So you can either create a new object with this with an extrude, or you can add it to an existing part, which I want to do now.
Making it one thing. So
now it's one part.
Yeah.
And then I'm going to do another extrude. Now just this surface. So the grid with the holes.
Yeah.
And I want it to be well, let's see. Starting from the surface, we need, say, 2 millimeters space below the PCB. Then how thick is the PCB?
Oh, whoops. Uh, 1.7.
Okay, so say 4 millimeters total to the top of the PCB, and then the M5 units are 14 millimeters high. So that gives a total of 18 millimeters from this surface to.
Did you take the spacer in account?
Do you mean, what spacer do you mean?
The black part, so if I'm...
Oh, the spacers on the header?
Yeah.
Oh, right. How thick are those?
Actually, so if I take it to the top, from the bottom of the circuit board to the top, it is 18.2 millimeters.
Okay.
And that's excluding like the bottom parts and soldering joints and the capacitors. Because it's the black part as well, which is like. But there's also like some spacing because it does not entirely fit. So it's 2.5 millimeter. That is for the black part of the pin header.
Mm-hmm. So I am now trying to get it to do something with the relative distances.
Yeah.
Ah, look at that. So I'm just saying, okay, starting from the surface we just defined.
Yeah.
Go up 35 millimeters, and that is the top of this surface, and then there's a second extrude which I still need to fix, because this is going to be also relative from the surface, and then with an offset of, well, what did we say, 18? So that's 18 millimeters, and then minus the shell thickness. And then this one is going to be just the 18 millimeters, and that gives us the top and the bottom of this surface at the right place.
Yeah.
Now you can see that I extruded the walls a lot too far.
Yeah. So how are you making like the top one fit in the bottom part? Already given that a thought, like having a rail or like some clicking mechanism, or
I haven't thought of, well, I've given it a quick thought. I think the easiest is to make them screw together.
okay.
With some extra work, I can also make it a clicking mechanism, but that's, with 3D printing.
Yeah, that will wear out. So
It does wear, yeah.
Yeah. But if you are going to screw it, then it should not be screwed in the plastic, but you need to screw it like bolt and nut type of way, so that you can disassemble and assemble it without wearing out the plastic parts.
Yeah. Well, there are these metal inserts you can use for screwing.
Oh, okay, yeah.
But also with well, depending on the material and the exact tolerances of the screw holes, it is possible to use wood screws in 3D printed plastic. It may be a bit tricky with harder plastics, but I've done it on multiple occasions and it does work.
Yeah, but I expect that you need to take it apart quite some times.
Yeah, so in that case, metal inserts for screws might be a better idea. But as you can see, we now have a very basic shape.
Yeah.
And then you can, along the edge, of course, add something to clamp the PCB.
Yeah.
I think it's easier to just add things to screw it to.
Yeah, you could screw it to the bottom plate, or like there's already 4 holes in the circuit board itself, or you could use like a rail on the top plate to fixate it, to put it in place, like having some sliders to the side. Or
Wait, you mean like something that goes over the top of the PCB to keep it down? Or
so what is the top and what is the bottom? Is the bottom part being screwed, or is the top part? Yeah, I expect the bottom part.
Well, it depends on what you want.
Yeah, okay.
I would suggest to have the bottom be like the base.
Yeah.
And then let the top be something you can take off.
Yeah. Okay, that makes sense. So if you take the top part that you are able to take off and add some rails to that, that would
Like around the edges?
around the edges, like if you do it around 4 edges or around every line on the sides, that would keep it in place.
Yeah.
Otherwise, you need to like screw them on the top.
Yeah, let me see. First, I think I'm going to split these two into 2 separate parts, so that you have a top and a bottom part. That's probably easier for, well, tinkering purposes.
Yeah.
That
you
means
could also use like cylinders on the top part that would directly screw the bottom part to the PCB.
so that you have like these poles sticking out of the top part, and you screw through the bottom part through the PCB into that.
Yeah.
That's also possible. That does, that would mean some extra screw holes in the bottom, and then.
Then you only have 4 screw holes.
Yeah.
And otherwise, you have like 4 to fixate them on the bottom, and the other one to connect the top part.
Okay, so then I need the exact position of the screw holes. Except these are not points, these are like circle shaped pads. Nah.
So the outer part of the circle, no, it's not centered. This is so from the bottom and the top, the outer side of the circle is 10.6.
Okay.
So let me show that what I exactly mean, because things might be lost in translation, as I'm probably not using the right terminology. Or is it? So I'm measuring.
Yeah, right. Okay.
Like this.
I think I've got it from the center to the top, and probably also to the bottom at 8.75 millimeters.
Oh yeah, center. Yeah. Yep.
Let me check here if it matches somewhat. Oh, it seems to be a bit different here.
Tracy states a high top part with standoffs with threaded metal insiders and lay the PCB flat on the bottom backside of the housing. Yeah, cannot be laid flat on the bottom. You need like some cylinder top parts on the bottom as well, as there's components on the bottom.
Yeah, so you need standoffs on both the top and the bottom.
Yeah.
And make sure the PCB fits between that, and with respect to the dimensions, so that the height of both the standoffs plus the thickness of the PCB is equal to the space between the top and bottom surface in the model.
Yeah.
Make sure it fits.
And exactly. Is it fit on the so the top part needs to be on the top, so it should not be an inlay in the top. It should be on top, otherwise it won't hold.
Wait, so are you replying to the chat or to
no, I'm just thinking out loud. So the top part is not only a flat part, it also needs some sides to align to the inside, right?
Yeah.
So that
Well,
it won't misalign.
I'm trying to design this housing such that the PCB fits exactly like inside the walls of the housing.
Yeah.
That would mean that the alignment is done by the walls, and then you have the standoffs for fixation.
But that would be harder due to parts sticking out being the USB-C and the Grove connector.
Well, what do you mean harder? I mean, if the PCB is at a fixed position in the housing, then I could just create holes in the housing so you can access the Grove connector and the USB-C connector.
I thought you centered it by putting the outside of the align the walls against the outline of the circuit board, but that's not the case. You're aligning it using the screws and cylinders.
Well, yeah, it's kind of both.
Yeah.
If designed correctly,
Yeah.
they should both fit exactly.
Yeah.
It's of course there's a bit of tolerance, but
Yeah. Yeah, I think it works for the sides. But the bottom part, yeah, you need like to have a cutout on the connectors, and then you.
so let's see. This is the center point of one of the screw holes. It's 8.75 millimeters on the top, and it's, let me see,
Smaller from the sides.
we 5.95. It doesn't come that close, but hey, why not?
Yeah, and Crazy is stating that the USB connector might actually stick out of the box. So it's not only the connector, but it's also the connector that's put into the connector. So the bounding box with connectors is larger than the PCB itself. Yeah, that's right.
Yeah, that's true, but that should be solved by just making holes for the connectors,
Yeah.
which is needed anyways because you need to be able to access the connectors even with the enclosure closed.
Yeah.
For external power. We are not yet designing a battery pack into it. It would need to be quite large.
Yeah.
So I'm just going to, maybe I shouldn't, but I'm going to assume that Bas aligned these
he did.
screw holes.
Yeah,
Okay.
He did not at first, and then I saw that they were not aligned, and he aligned them.
Okay. So from this hole to the edge, where's the edge? There's the edge. Is 8.88 millimeters. And then we can find the oh, I thought I had some axis of symmetry, but I don't, because I hate all the panels. Oops. Because these planes are in this configuration, they're just the planes which you can sketch on.
Yeah.
But if you're sketching, they're also the axes which you can assign symmetry to, so they act as lines. And I am in this case going to let's see if I can center it. because that would be, it would make some things quite a bit easier.
Yeah.
Um,
You can mirror them or add symmetry.
yeah, I might need to add a Okay, no, okay, wait, I can add a midpoint on this.
I have to take a short toilet break, if you don't mind.
Sure.
I'll be back in a minute.
I'll try to keep your public entertained.
Sorry?
I try to keep your audience entertained.
Yeah, thank you very much.
So, I'm just thinking about how to center this whole thing around these axes. It's probably easiest to add a point on these. I'm still wondering why I'm not seeing these planes as another line here, because that's what I would have usually. But anyways, I can add a point on this line, and it already shows the constraints for midpoint. I'm not sure if you can see. And if I add that point and I say, okay, this point should intersect with the... It doesn't. This is really strange. Yeah, okay, so I can tell it to align with the center point, and then the whole assembly should be centered, although I see that I have not defined a height for the entire PCB, which is strange. Apparently the constraint fell out sometime. Fix that easily. Ta-da! Okay, so now it only has freedom of movement in one direction, which is this direction. And I could also fix that, but I'm not going to, because it's not really needed at this time. Because the board is only symmetric in the horizontal direction, not in the vertical direction. But I now have these, this point, and they both represent screw holes. And I can mirror those over the axis to the what? Oh, 1 minute and everything breaks. Okay, so now I add these 2 points. What is happening?
What?
Well, I was trying to mirror these points to the other side, so I don't have to draw them multiple times.
Yeah.
So I added a oh wait, I see. I used the symmetry button instead of the mirror button. That explains a lot. So I use this mirror line. Yeah, okay. And then I just select these points, and you can see them appearing here and here on the screen. And then I have 4 points which represent the screw holes, and I can now add another if I want. I can either add another sketch, or I can use the current one. I think what I'm going to do is in this sketch add the poles for the standoffs, and then split the entire enclosure at once, and then I can just retract the top surface of the pole by the thickness of the PCB, which should make it exactly the right dimensions.
And the bottom part.
Yeah. So I can create a circle with well, any radius I want. At all the 4 points, and then say, okay, these should be the exact same radius, which I'm going to do now. Oh, oops, I used the wrong point here. So those are 4 circles, and then you just select them all and make them equal radius.
Yeah, B.
That's a good question.
Already measuring.
What's the radius? Let's see.
2.
Are they okay? Radius of 2 for the holes in the PCB, right?
Yeah.
So do you want to work with inserts or with just screwing into the plastic itself?
I'd rather have inserts. So.
Okay.
Needs a lot bigger. Needs to be a lot bigger.
So then I'm going to look up. Actually, does anyone watching have or know good inserts to use? Because I've never worked with inserts in designing. I'm just scrolling here.
Do you need to like print these firm or hammer these in or glue those tight or? I only have the cheap Chinese ones.
Okay, yeah, I believe the idea is you print something and then you press them in, so they just stay in based on friction.
Yeah.
And then especially for example these ones, as soon as you put the
nice.
screw in, they expand.
Yeah.
So they stay in like they should. Actually, it doesn't really matter what exact inserts you want to use. You can also always determine that later.
Crazy stating, CNC Kitchen had some videos about it, using a crappy soldering iron. So you heat them up to make them stick to the plastic as well.
Ah, okay.
That could work.
That could certainly work. For now, I see... I'm just going to go with a 5mm hole size for the inserts. That does mean no, it should work fine. Okay. So these are the going to be the screw holes, and for the moment I'm going with M3 screws. So I'm going to make them 3. Oh. That was not intended. 3.5mm. I should probably add just another variable with screw diameter and make it. I think M3 screws are like 2.8. And then we can base all the other dimensions off of that. So I'm going to make this screw diameter plus, well, whatever. I think so then there's...
Oh, this, I think it's 1 then, that I made a mistake. So it's 2 from outside to outside. So radius is like from the center of the...
Okay. So let's see. Can I measure that? Actually, I'm not sure what like what the PCB factory uses as the outline for the for drilling the hole. So if if you say the hole is 2 millimeters in diameter,
Yeah.
that doesn't really match with the PCB drawing. Then
Okay.
are you sure?
Oh, well. Sorry. It's actually 3, so 1.5.
Okay.
So this is due to this not being set to 0 at start.
Ah, that explains.
Yeah. Was looking at the digital part, not at the analog readings.
Okay, so the holes in the PCB are 3.2 millimeters.
So let me measure the other stuff as well then.
Or just 3. That means you can use up to M3 screws. Because I think M4 is already larger than that.
Yeah.
So we can just assume M3 dimensions from here on. Then I'm going to make the hole for the I think the hole through the bottom is going to be the screw diameter plus, well, 0.5 millimeter. Much more isn't really needed. And then these would be the holes through the bottom and up to the PCB. Then there's the PCB with the hole in it.
Yeah.
And then there would be the standoff with the insert in it, which you screw into. Then we need another circle on all 4 corners for the actual pole of the for the actual standoff. Okay, so I think I got it now.
On the left side they are 4.5, and on the right side they are 4.
What dimensions are you?
That's like from the outer side of the circle to the outer side of the board.
Okay. So wait, then it's not symmetric.
It's not symmetric.
Huh. Interesting. Oh, I can also see it in the drawing now. Yeah. Huh. Okay. I mean, it shouldn't be an issue, but then our let me see where the difference is, because measuring from this outer circle to from this circle to this corner, I see X difference 2.08 millimeters. And then on this side, from this corner to the same circle, it's 1.12. So it's probably there that the difference is. That might also mean that I cannot assume everything to be centered. That's okay.
So
we can just delete these because they're not useful anymore.
no. So if we let go of this and just look at the outside of the board.
Okay. So I need to re-measure the placement of the holes on the right, because the holes on the left are still accurate. I use those for reference.
Yeah.
So these are going to be at x 5.33 from the edge, and these are 5.95. Yeah, no, those are not symmetric anymore. And this one isn't either. These are aligned though, perfectly. And then I can just
redesign the PCB to make it all symmetrical, nicely centered, whilst the boss isn't looking.
Well, I could, but then the PCBs that have already been fabricated wouldn't be of much use.
And shipped and set up. So this is just adding another factor to making it an advanced design, other than the starters.
Yeah, and of course this was never really meant to be a very.
It was just to use it like as a few holes and wear it around your neck or hang it in some specific place.
Yeah, okay, so now these should be right. I'm going to check the dimension, the distance from here to here again, because apparently sometimes the centering of the tool isn't really correct. So it should be 4.75 and it is 5.27. But on your PCB, are the M5s within the lines?
Yeah. But they are more to the left. So yeah, they are within the lines, but they are to the bottom left.
Okay.
So there's some spacing left on the top and the right side.
Okay. Well, then it's a bit hard to use these files for reference because apparently they're not exactly accurate.
Yeah.
How large is the difference?
Yes, really tiny, like 0.5 millimeter.
Oh.
It's not. It's.
Yeah, that shouldn't be too much of a problem, I think, because that's also more or less the tolerance.
Yeah, 0.53.
Okay. So then I am going to take this distance, which is 9.91, and this distance, which is, well, what is it? And just subtract some. 11.37. And then this should be around about 11. Now this is of course just kind of guesswork, but part of the trade.
Yeah.
And then what's the distance we come out on this side? It is 9.9. As you can see, working from an existing object or design is
Yeah, it's
a lot
hard.
a lot of constraints and not
Yeah.
that much actual drawing and designing.
No, but these are like the real life challenges. So if you know that you run into this at the end, then you think about designing your circuit board in a different way.
Yeah, definitely.
So I was not thinking about this as well. Like for me, symmetry was all about beauty and not about 3D prints.
Yeah, but symmetry, it's aesthetically nicer, but it's also it helps with designing.
Yeah, I understand.
It's that simple.
Yeah, and I think this entire process makes it even more clearer.
So that's at 4.57. I'm again checking all the dimensions because at some point they should kind of match up.
Yeah. So you have not much space between the cylinder holding the
yeah, that's not that much of a problem.
Okay.
I mean the holes that are in here are for the screw that goes through the bottom.
Through the bottom, yeah.
And then I actually still have to draw the circle for the inserts.
Yeah.
Might as well do that now. Because the inserts are, well, it said it somewhere here. 4 millimeters. So it's not that much difference with the.
And it's an entry.
Yeah. So I'm just going to assume these inserts.
Yeah.
Can of course change later, but these are.
I actually have some inserts lying around here.
4 millimeters, they say, suggested hole size.
Yeah.
So I'm just going to do that. As you can see, these are going to be a lot of concentric circles, which is a pain to select all the surfaces when extruding, but it's just how these things work. I'm going to select one circle and then all the others to say, okay, these should be the exact same radius. And then assign a radius to one of them. I think I'm going to do that here as I've done with the others. That's going to be 4 millimeters. So as you can see, there's not much of a difference. I think I'm going to make it a little bit bigger because often 3D printers make it a little bit, make their walls a little bit thicker than in the design.
Yeah.
And then, well, the diameter of the balls is not really that important for definitions. It's important that it doesn't intersect with anything else. But right now there is 0.6 millimeters distance between these two, and that should be enough for tolerance.
Yeah.
And what I can now do is, well, first show you what happens when you edit the sketch on which an existing extrusion is based.
Yeah.
So I'm now going to have to select all the extrudes and add the missing surfaces.
Yeah. So this is the bottom plate, or this is the top plate? Bottom.
This is the bottom.
Yeah.
Yeah. to prevent this, I could have made a new sketch on this surface.
Yeah.
So I can just in the beginning extrude everything, and then later make a more detailed sketch for the holes and fix that. But in this case, I wanted to simplify the extrudes themselves by extruding everything at once and then splitting the two halves.
Yeah.
So
Makes sense.
it's a design choice.
Yeah.
And neither of them are ideal, but they both work.
So you need a hole in the bottom as well.
Yeah. Oh, that's a good point. Actually, I should remove the material from the inner hole at the bottom part. But now you can see the top surface intact again.
Yeah.
And then we're going to get the bottom surface and deselect these inner holes. And then we can later we can make them inset, so you can the screw is inset in the housing.
Yeah.
It doesn't have to be, because you can also use the screws as feet.
Yeah.
It's just preference. Personally, I would make them inset.
Yeah.
So now you have holes in the bottom.
And you need the bottom is in the top part. So there does not need to be any guideline or slider or whatever. We're using the cylinders for that.
Yeah. Yeah, exactly. Of course, it's not a very it's a large PCB, but not that large. That should be enough for sturdiness.
Yeah. Otherwise you could use some foam underneath in the middle.
Yeah, or you can always add if you're not content with the sturdiness of the design, you can also add
bumps,
some guides or some supports later.
Yeah.
But I think this will do.
Yeah, cool.
So we're now going to add the standoffs to the wall extrusion. And then you can see that you have four little holes in the corners.
Very cool.
And then you can, of course, now they're still joined.
Yeah.
And this is the point where I am going to see if I can offset the. Let's see. I want to duplicate the surface at a distance, and I think this is the right button for that.
I really like how this comes to play all in now we're over 2 hours now. Yeah. Really like the process.
Bottom surface. Num. Okay, so these are the surfaces that need to split the and then
you need a cylinder on the bottom part as well for the distance of the circuit board.
Yep. Now the bottom itself is of course defined by shell thickness. And then after the bottom we said what was it, 4 millimeters
from the top to the bottom.
Yeah.
To include
So
this 1 point, what was it again?
this is going to be 4 plus 4 millimeters.
It's 1.5 for the circuit board.
So now we have oh crap.
What?
Since I selected only these 4 circles and the wall, they have now been created into 5 separate surfaces.
Okay.
It works, but it's not convenient, so I'm going to
roll back,
delete that.
Yeah.
And
It's possible, like, to deselect, to disable certain parts or layers to prevent this from happening.
Well, I am going to do the same, but now just select the entire bottom of the part, or if I can, I can't use the base plane, unfortunately. That's not really an issue. So I can just use the bottom of the part. And move it up by oh wait, this is again not exactly what I wanted. Yeah, this is more like it. I would like to offset this entire surface. Look, and now it's just a surface because just a moment ago I was moving the entire face of the bottom up, which meant the part just retracted. And now I am creating an extra face.
Yeah.
So that's going to be shell thickness plus 4 millimeters, we said. Which gives us basically a tool to split the housing.
Yeah.
And now we can do a cool trick, which is actually splitting the housing using this part, and the entity to split with is the surface we just created. And now we have a bottom and the top part, and we can hide one part and the other stays visible. So this is currently the top and the other one is the bottom, and now we can do what I was just doing incorrectly, and say, where was the button again? Move face and select the 4 poles, and then what was the thickness of the PCB?
1.5.
Okay, so I can move these by the other way by 1.5 millimeters, which gives space for the PCB.
Yeah.
And then I can.
Now, how much do you still have left for the bottom part?
2.5 millimeters.
Yeah, that's more than enough.
Okay. And then I'm going to create a variable with the thickness of the PCB, which is not necessary, but probably a good idea. PCB, which is 1.5, you said. Oh, oops. And there. And then I can change this to PCB thickness. Now, of course, there needs to be space for the inserts, the screw inserts.
Yeah.
So I am going to.
Not in this part, right?
You're right.
Only in the top part, and it will be held together because the screws itself are M3 and the holes are M3 as well.
Yeah. So
these need inserts.
Yes. So there's going to be another extrude of these surfaces, which are the little rings that are the difference between the holes that existed anyways and the poles.
Yeah.
And then now it's an add extrude. It needs to be removed.
Yeah.
In the other direction. Up to face, well, up to this face, and then with an offset, of course, because it needs to go in there.
Yeah.
Of, let's see, okay, other direction offset. Okay, now we can see it's removing material from in there.
Yeah. What would it be, like 5-6 millimeters?
Let's see. At least if it's specified.
That's
so
much more.
This should be 4. Then I think from top to bottom it's 6 or 8.
Yeah.
Let's just make it 8 to be sure.
Yeah. But this needs to be an insert as well as the bottom is wider than the rest of the thing.
Sorry, come again?
So if you look at the design of the insert, then there's a ring on the bottom.
Yeah. Yeah, if I can find the exact dimensions of the part, I can fix that. But well, I can also guess, of course.
But there's also other screws that are just rastered bolts inserts that do not have the outside, like
the flange.
Yeah.
Okay. Do you have a link or something?
Or I ordered a few. I have a box here.
Ah.
I can get them and measure them. Shall I do so?
Yeah, sure. Can you also put one under the microscope?
Yeah, will do. Hold on.
Does anyone in the chat have any suggestions for, things to add to the design? I'm going to get a cup of water.
Yeah.
Be right back.
So how's everyone doing in the chat? Well, I try to.
I'm back.
Welcome back.
Thank you.
So these are actually four. Let's zero this again. So
What's the diameter at the round part of the inserts?
at the outside it is. Oh, this one seems dented. So 4.2.
Okay.
Yeah, 418.
See.
And the height of it is not that high. So it's only 3 millimeters high.
Okay.
But then you don't need any insert kind of solution.
Okay, so then this can be. What was the height of the inserts?
3.
3. Okay, so I'm going to make it 3.5. So, and then there's space for the inserts. There is an offset on the surface for to accommodate the PCB, and there is also a hole in the bottom.
Yeah.
To stick the screw into.
Yeah. So the bottom and the top part are together. Is there a way to like fixate that they do not misalign? Not yet.
Not yet, indeed. But that should be doable. Just thinking of a way to do that.
Like having an inner line and outer line, or
Yeah. I might have something for this. It's not something I've done before, but I have an idea.
okay, cool.
So, I'm going to make another sketch, this time in the perpendicular plane. And as you can see, I've turned on the hidden edges, so you can see the offsets and the inside of it, and also the walls of the PCB.
Also, it is pretty.
Ah, thank you.
Or is this from the wrong chat again? Joking. Yeah, I really like how the circuit board is in the inside as well.
Okay, I'm trying to get a reference point. This is probably okay. In my sketch, I'm going to project. Couldn't project. Oops.
Is one of the sides thicker, or is it just the way that you see it? Is the outside line as thick on all sides? Because it looks
the wall should be the same width
everywhere.
Yeah. So I'm trying to get a reference on these lines so I can use them in my sketch.
Yeah.
Except they're somehow misaligning. It doesn't really matter. It says could not project. Okay, so this is a useful reference point, and then what I'm going to try and do is make a sketch of a profile I want to cut in the side.
Okay.
And then I can, I think I can sweep the profile around the entire wall, so you get a bit higher part on one side and a bit lower part on the other side.
Cool.
Actually, this might be an alternative for splitting the shell. Except we've already done that, so I'm just going to see if this works.
Splitting the shell.
Oh.
How do you mean?
Well, we had this one block of material.
Yeah.
And then we used the one surface to split it into two parts: the top part and the bottom part.
Yeah.
And what I'm going to do now could also have been used to
Split them in two.
to split them in two, indeed. Except then the standoffs would need a separate splitter. But okay, enough talking. I need to draw something.
Yeah, concentrate.
I'm trying. Okay.
yeah, I won't bother.
So we would want it to be, I think, like, then this is useful. This is useful. I want it to go right down the middle, horizontally, and then it needs to be centered, so the same distance from that line and as to this. Oh, can't do that.
Sleep well, crazy. You can still turn it on and we will be continuing and you can go to sleep.
Bye-bye.
Goodbye.
So these two need to be equal. And then we have a single line. We need some more lines to achieve this. Connecting to there and connecting to, well, whatever else. Now I kind of do understand people getting sleepy because this is not the most exciting matter, but
this is exactly how it works for real. Like you can have this all hyped up stream about someone doing it in 5 minutes and skipping all the non-interesting parts. But whenever you are designing yourself, you run into these things as well. So I think it's beneficial for people to see how it really works and not have the slick stream.
Okay, so now we have a side profile, as you can see.
Yeah.
These three lines. Actually, I can delete these now because they're not necessary anymore. Or are they? Oops. We deleted them too early. Okay, so side liner. Then I want to add some dimension to it because now it doesn't have any constraints whatsoever. Probably 2.5 millimeters should do. This means, no, wait, 2 is probably enough because this means that there's 4 millimeters right here to align
Yeah.
the two. And now let's see what I can do with those two. I have two. As I said, I've never done this before.
Yeah.
That makes it more fun because
and more real as well.
Yeah. What I want to do is sweep what it just made. So it wants me to sweep a face. I don't know. I want to sweep a surface, so I can just select these edges, which I just made, and then I will use the edge of the of the top of the bottom part.
It's actually very cool. So you can even make shapes in how it fits.
Yeah. And then I'm going to use this surface, this edge, and this edge, and this edge. Yeah, it's working. And this edge, and this edge, and I'm selecting this edge
and you
all
need
around.
The inverted part for the other part.
Yes.
Oh wow, cool, man.
So now I've made this profile.
Yeah.
Edge aligner profile thingy. And with this is a standalone surface, so it should exist also within this these two objects. And now let me see if I can. Yeah, no, I'm just gonna leave it at this for the moment. I'll fix the details later in the design.
Yeah.
Before printing, but for now it should work, because now we can split and union two things.
So you don't have to do this for the top part as well?
I suspect.
Okay.
That I can select these two parts, and then I can then I will just select the surface, and that should it creates two new parts, so it works. Liners or whatever, and then let's see what we have here. First, we have the bottom.
Yeah.
And you can see that it now has a cutout on the side. And the rest is contained in these three parts, which has a lip. Right? I think you can see. Yeah, okay, so this now has a lip going around. So we can kind of undo what was just done and do a union. Whoa. Clicking all the buttons. Union these three, and we get back the top part. Right? Yeah. And now we have a bottom with a cutout and a top with a lip.
Very
now,
cool.
of course, the let me think. The PCB goes on here. Well, no, actually, I'm trying to think what's logical, where to put the lip and where to put the all the cutouts and stuff, because one side is going to be the part you put the PCB in, and the other part is going to be like the lid you put on.
Yeah.
Um,
Or you can raise the bottom a little bit. The sides.
yeah, because like this, there here are going to be inserts, and you put in the PCB, and then there is the bottom which you just put on and screw. And let me see how much space between these two. 6 millimeters. So there is some space to make an inset for a screw here.
Yeah.
Do you have those blockhead M3 screws, or are they like round heads?
I'll show you. Oh, they're actually not that clear. These.
All right. Yeah. So what's the diameter of those heads?
That's 5.4.
Okay.
And the height is 3.2.
Okay. Just going to add more circles. Whoa, that wasn't supposed to happen. Alright.
That's quite big. Then you need like a thicker surface for the bottom to make it work. Otherwise you go through.
Because, okay, what was the thickness of those things again?
3.2.
Okay, yeah, that's pretty thick.
Yeah.
We'll see what we have left after this.
Yeah, and otherwise I can order new
Yeah.
screws for it.
So,
Or turn them into like a distance holder.
let's see, select all four. Set equal. Put a distance on, dimension on them. They got to be 5.5 or something, with some margin. Okay. And then we can make an extrusion of all four. We remove, and then 3 point plus 3.3, right?
Uh, 3.2.
3.2. That gives me some space. It leaves.
That's actually 3.
Okay. Trying to find out what the distance is between the new inner. Okay, wait. This has radius.
Oh,
Diameter 8. This is diameter.
That's cool. Using the
5.5.
distance as well.
So there is 1.75. Oh wait, is that correct? There's 1.25 millimeters left on both sides.
Yeah.
Here and here, between this and this one. So it's probably enough to keep it together.
Okay.
This should work. So there's an inset on the bottom.
Wow.
There's space for the PCB on the top.
So much detail.
Now we have, well, I mean, it kind of looks like an enclosure.
Yeah.
Just needs more holes, right?
Yeah. Both for fan and for connectors.
Whoa, 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 whoa. What's happening? I'm going to use these screw holes as a reference, I think.
Yeah.
So that's, yeah, it's probably a good idea. Then how much space around the USB-C connector do you need?
That entirely depends on the USB-C connector. I have one here, which is 10.5 and 6.5. But yeah.
Okay, so that's the plastic included.
That's the plastic included, but yeah, I would make it bigger as there's different USB connectors, like at maybe 2 millimeters to each side. Round it up.
Let's see if I can find the center of this connector. Right there. 70 millimeters from the left. Yeah. Okay.
Yeah, I could do so. But that's something that you could use adhesive for. So Elbora is asking, are you planning on something like anti-slip under the enclosure as well? Thanks.
Yeah, I mean there are these cheap rubber or silicone adhesive feet you can just put on there to keep it from sliding everywhere.
Yeah.
That's probably the easiest.
Yeah. Yeah, I don't think it should be part of the design. At least I don't know if you have like a multi-material 3D printer. I've been to the Lego factory in Billund, and they had those special molds. I think one mold was 100,000 euros, and they were able to create one brick with one of those molds, and they could even have like multiple materials, like have rubber and plastic on the same mold.
Oh, okay. I named the parts the wrong way around. Oops.
As Bas is still in the chat, I really an injection mold costs thousands for a complicated part. Yeah, 100,000 in this case. So those were their crown jewels, and at that time they already had like a robot spinning around doing all the stuff and packaging, and actually whatever fell on the ground was put into boxes, and at first those boxes were for the community, so where you could get like a box with random components, so no electric components, but like all the special Lego Technics or Lego, whatever girly Lego stuff. But then they decided to no longer give that to the community, but to earthquake, where children were out of toys, and ship those boxes to those special areas where kids need like some distraction. Like really cool.
Okay, so
6.5 by 10.5 with some
let's say 11 by 7. Haha, 7-11.
Pun intended.
Maybe.
It's nearly 11.
Yeah. Anyone in the chat for who 11 means bedtime? 17.5. Okay, so and then the distance between these two should be shell thickness plus 4. No, wait.
The center needs
4 millimeter minus. Where's my? Here is it. So, okay, so this should be, if I am not mistaken, the right position.
So the bottom line is the top of the circuit board?
Yeah,
And the bottom
probably,
of the...
No, wait, I'm probably doing stupid things now. I should use this as a reference for the position. Because this should be shell thickness plus, what was it? 4 millimeters. And that's the top of the piece. Should be plus 1.75 for the USB-C connector itself. Whoa. Yeah, okay. And then this should be the position of the USB-C thingy.
It's 4.8 is the USB-C and the PCB.
Okay. Like the total height of those?
Yeah, total
two?
height of both.
Okay. Then some fancy fillets of, well, not this much,
No.
obviously.
Cool.
Then I can also just add the hole for the growth connector.
Yeah.
Which is probably a bit more well defined because growth connectors are not fancy plastic things with
865 by
60 millimeters.
3.6.
Sorry, what? 3.65?
8.6 in width. What is it? 3.56 in height. For the
Is that
for the connector,
that,
like for
yeah, okay.
this part. Or is it-
I think I'm going to go with the outer dimensions of the connector instead of the dimensions.
Which is 10 by. And now I'm including the circuit board as well. 6.8. 6.85. 6.9. 6.9. But that's including the PCB.
Okay.
Which is 1.5. Oh.
I'm thinking of a good way to define these dimensions, but it's just I don't know. Maybe it's the time. I mean, we've been doing this for like 3 hours now.
In 2 minutes, yes.
So, the top of the PCB is defined as, we're just going to draw a line, which is horizontal and which is 4 millimeters. Oh wait, L thickness plus 4 millimeters, which is there. So this is the top of the PCB, and then the center of the connector I think I'm going to use is, well, it's USB-C connector, so I can find that here.
So boss is asking if we want to join the people at the Hackaday Remote.con hangout.
That's also fun.
Yes. Nearly there with the design.
So, okay, there should be about 3.05 or 3 millimeters or 3.1. I'm going to go with 3.1 divided by 2. And then for this one, the same thing actually. So I'm going to add a construction line here in the middle, add a point on there which should be, oh okay, point on the line which should be in the middle of the line, and then say, this connector is, what was it, 5.2 high, so the center should be, no wait, I can just put this on the bottom, it's noise.
Yeah,
these two are horizontal to each other. Oh, it doesn't do that, oops. These intersect. Ha!
Yeah, works.
So that's for the connectors.
Yeah.
Oh no, wait, I still need to define the distance between these two. Center distance is 16. between this and this one. And then I can just make them reappear and extrude.
Oh, cool that it extrudes from the bottom part as well.
Oh wait. No, okay, it should work. Extrude, and then hide these two. Extrude these two, remove. Up to face. It's going the wrong way. Up to let me see this face. Can I? Oops. Yes. Okay. Then merge scope both parts.
Yeah, cool.
And I should probably also define a second end position. Which is the other side of the face on the other side, because otherwise, if we make something in between here and here, it will just go straight through.
Yeah.
Which is, it's probably not going to happen, but it would make for nasty surprises in the future and hours of debugging.
Yeah.
So to speak. Ta-da! Connector holes.
Yeah. Very cool.
So now this is going to be tricky with printing.
I would just cut it off.
Yeah, I mean the printer will try anyways, but if it fails, you can just cut it off because it's going to be behind the edge anyways.
Correct. Yeah.
And in the other part, it's just going to be a little cutout.
Yeah.
Now the only thing left to do is to create some holes in the for venting. We can make holes in the back. We can make holes in the side, the top, the bottom. What do you think?
I would say create vent holes along the interspacing between the atoms. So there's 1, 2, 3 interspacings on all sides. Or what do you think for airflow?
So there'll be 1, 2, 3 here and here as well.
Yeah, like on the same line as the raster is.
Yeah, I could do that. I'm not really sure how much air should be going through here anyways.
No.
I was thinking of just making like a line of vertical.
Oh, the small ones that are in the device itself.
Yeah, but just like this, and then just a lot of them on a row.
Oh, okay, yeah, could do that as well. Yeah.
Now, if you want to put it upright, that would mean you get convection at least to the top. So the top's the first one I'm going to draw, and I'm going to put them all in the top part because it would just create extra work to also let them go through the bottom part.
Alboro is asking, are these M5s getting that warm that you need this ventilation? Actually, because we're powering them USB-C with 3.1 amps, they're getting quite hot. So might be due to enabling Bluetooth, Wi-Fi, putting all the LEDs on. So might reduce it by disabling functions or dimming the lights. but yeah, we do need some venting.
Okay, so I think it's just going to be holes like this. Just give them some dimensions.
And then it's easy because they just repeat itself over the edges.
Yeah. I'm just going to make a linear pattern again, like
Yeah.
with the holes for the atoms themselves.
Yeah. Real fancy box.
Yeah. I think I'm going to work on it a little bit more after we finish the stream because
Sure.
perfection.
Yeah.
Anyone watching will probably see it on Twitter sometime in the next days.
So some inlays as we have on the atoms on the top would be cool as well. Like the tilted inner part.
Wait, what do you mean?
Like if you look at the atom itself, those are like not flat on the top. So if you cut them out, have like the similar experience for the inside. So not have like a straight line, but like a slightly curved line.
Oh, okay.
You're saying something in chat. Removing transparent window from the M5 stack lets you get rid of a heat. Oh, okay, yeah. But yeah, you can't use it as a button anymore. Yeah, correct. Yeah, could do that as well. Yeah, I haven't figured out the software yet. So that all depends. Might be a way to interact with the device by selecting functionality by pressing the button. So I think for now we're going to leave it on. But maybe it will be controlled by a different M5, like a Core 2 with touch. Then you don't need that click functionality anymore, and then we can just take off the shields.
Pattern of this, and then I don't know.
It's like an artsy view.
How many do we want? 42.
As much as possible.
Oh, okay, so then they end up here. That's maybe a bit too much.
A little bit less. Yeah. You can still use that as a button, but it will be like for blind people as well, feeling all the notches.
Okay,
how many will fit? It's like 8, 9.
Well, we can do 4 groups of like 5, or we can just make it one big line.
Yeah, if you heat up the light, you will have heat, Brian. We already subtitled the screen, but we did not think about people that are having sight problems.
Heat braille sounds like an interesting experiment, but I'm not sure I would like to be a test person.
Elbora is stating, as a finishing target, now find a nice spot to embrace Warranty Void logo.
How about here? Do you have an SVG of that?
Yeah, it's on my kit.
Okay. I can just import that and.
Yeah.
Okay, so we want some airflow from here.
But I just used the OCR logo, so.
Okay.
OCR font. No, not for this one. This is what is the Arial bold, I think.
Oh wait.
Can you do it around the corner as well?
I don't think so.
I think we'll overcomplicate it.
Yeah, it's like this works with surfaces, and every surface is well, at least the surfaces you can draw on, they're all straight.
Yeah,
So
yeah.
as far as I know.
Yeah, and you don't want it like on the curved surface as there's like the screw section. So you want to
also
conceal that. Yeah, cool.
So let's see.
Will that fit, or do you need to make it a little lower, as you don't want to touch like the top of the surface?
What do you mean?
So if you look on the inside, does this not touch the... Oh no, it does not. Okay, cool. Thanks.
So I think I'm going to leave it at this.
Yeah.
So that's a group of 5. And then
and then you have 5 for each LED, for each atom. That's
exactly.
very neat.
And then I can make just another pattern with spacing of 28 it was, right? Because 4 millimeters between the things, and then 24 for each.
Yeah.
And then times 4. Ta-da!
Patternception.
Haha.
Very fancy.
Okay, now I need to add 2 construction lines to center them right here. Another one right here. I'm going to say, okay, these 2 are equal. And then we have surfaces we can extrude.
Wow. Is it possible to print transparent as well?
Yes, depending on what kind of printer you have, it will be pretty or not so pretty. Transparent filament exists.
Okay. Yeah, I don't think you should do this in transparent, because then you will see the screws as well, and I think it is much more neat. So something that resembles the color of the atoms, or a little bit darker or lighter, is very cool.
I might have access to an SLA printer soon.
Oh wow.
Those get a lot better results with transparent resin.
Yeah.
But then it might be a bit of trouble to get the inserts for the screws in there, because resin is not thermoplastic. So anyways, we got some holes.
Fancy. Very fancy.
And now
I think you should skip them on the bottom.
I can add 2 groups of 4.
You could, yeah.
Fun thing is, I can reuse the same sketch. So
even if those only are only 2?
Yeah, sure, why not? I'll just select
them
these.
manually. Oh, okay, cool.
This is going to be a little bit more tricky, because the sketch is here and I want to extrude them here. So I need to say, okay, extrude up to this face.
Yeah.
and then remove, of course, and have a second offset distance of, wait, what? Oh yeah, no, second end position, excuse me. And then up to the face as well, no, the other side. And that gives you more holes.
Cool.
Now this gives you convection from bottom to top.
Yeah.
You can also make some in the side if you like.
Yeah. Would like to, if we could have like the same ones on both sides.
Okay. Then I gotta make a sketch on this side, say, and then no wait. And I need to steal one of these points for height reference.
Yeah.
So I'm just going to get this one and this one. Yeah, that's probably fine. Project them onto my sketch.
Yeah.
Then
Albora is saying it looks like a bit like magic to me. Very nice. I probably would just try to copy the entire pattern to the other side. That's what I thought as well.
I might be able to do that.
No, it's not trying to influence you, but like, why are you using one or the other? It's like personal preference, or.
Actually, I didn't even think of it, so.
Okay.
We're just going to see if it works.
Thanks for the suggestion, Rob.
Yeah. See if it works.
And then you extrude through the entire enclosure.
Aha! Look at that.
Does it align as well, or do you still need to align them? Yeah, you need to align them, but that's not an issue. And it is still a group.
Wait, what? Oh, yeah, right. That's...
Yeah,
nice!
Very cool, yeah.
Okay, so these align horizontally. And then I'm going to do the same trick as before. Construction line here. And construction line right here to this side. Make them equal to center. And this gives us holes the right side. It was the top side. This was the bottom side. And then we can just unhide these and extrude all of these holes.
Yep.
Oh, oops. The fun thing is, because these are all constrained and linked to each other,
yeah,
it's quite easy to move or resize them all at the same time. So you don't have to do everything, manually, changing stuff in your design.
Yeah.
Although I'm now, you can probably see that they're not perfectly aligned here, because the PCB is not symmetric. Do you want them to be aligned with the M5s? Or
with the M5.
Enclosure?
Yeah, with the M5s.
Yeah, okay. I can fix that probably.
Don't know if Ian is still in the chat, but I removed the film on top of the pin.
Base to this side. So Now let's see how to correct the placement of these, because apparently these are no use.
They are aligned to the top part. Not really.
So I'm going to make another point on this.
So if you have the middle of this one, yeah, to the middle of the yeah,
And
that's
just make
it.
this
That's it.
vertical.
Yeah, perfect.
Pling.
Wow.
Look, it's behind the
Oh.
but mind you, there's not going to be much light in here.
Yeah,
so
yeah, I was thinking that. So you won't see that. Yeah. Yeah, I'd rather have it like all the same than. But you cannot extrude it then to the other side.
Yes, you can.
As long as you stop it in time.
Well, as I did with the other surfaces. Okay, wait. You just select all of them.
Oh, and copy them to the other side.
Well, you just tell it to extrude up to a certain phase.
Yeah.
But you can also specify the start position.
Ah.
So in this case, it means just saying, okay, I want to extrude up to the outside here.
Yeah.
And the second end position is the inside.
Yeah.
And it will only extrude between those two planes.
Yeah.
Creating holes. Ha.
Yeah. Very cool.
And then you know, I think all the holes are in place.
Yeah.
Could do some styling.
So Boris say, very neat, brilliant, but you can't extrude, hold my mate. Instead of hold my beer. Yeah.
Good one.
Yeah. Yeah, this looks amazing.
Okay, so can we do that here too? Okay, it's probably a bit too much.
Oh, yeah. Yeah, yeah, that was what I was talking about, yeah.
Then also chamfer for all of these. It's now saying, no, wait, I can't. It's too much distance, but just wait a second. Make it less distance and ta-da!
Wow. Brilliant.
I can probably also do something like that for the ventilation holes. Except that's a lot more work.
Yeah, no, I just like this is the ventilation holes are not the things that you are going to see, as you only see the top side. So the aesthetic is already in the symmetry.
I wanted to say I can just do this edge, but I can't because it doesn't make
sense. Yeah.
It does look kind of nice.
Okay, if you want, be my guest.
1 hour later.
Yeah. if I'd know, I would have dropped my board so you can fit it. So is there like a standard format of 3D printed stuff that could exchange in between different programs?
Most, well, for 3D printing, STL files are common.
But will it allow you to make changes to the files?
No.
Okay.
The file formats for 3D CAD software are, well, often a bit proprietary, but STL is common for 3D printing. Like if you have a model and you want to print it, you need export it to STL, and all slicers can interpret that. So and now,
wow, looks so slick.
if we can fix the color, because I don't like this blue. Appearance. What do you think? What color should we make this creation?
Yeah, it needs to stand off against the atoms. So it needs to be either darker or lighter.
Okay, let's see what I make these. Okay, so
is it possible to place one in on the board?
Yes, but not.
No, just as a reference.
Yeah. Okay. We first edit the material bit.
Yeah.
It doesn't do 3-digit hex colors, apparently.
So I think it should not be too obvious that you're carrying a device, so some darker blend-in colors would be nice.
Yeah, of course this is not going to be the exact color of the printed part. But
depends on what material you use.
It's just for reference.
Yeah.
Oh, wait. This thing needs to be rotated. Like that.
Yeah.
Oh, it's going hard. Then just freeze it. Nah, okay. I'm going to align it with one of the holes. Still too lazy to assign proper mating connectors, but whatever. Something like this, probably.
Yeah.
Then, okay, maybe a bit higher. I don't know.
Oh yeah, it was not right on the board. There was this distance holder and.
Oh yeah.
Yeah, cool.
Makes sense.
Very, very cool. Could you make some snapshots and post them on Twitter?
Yeah, sure.
Does not have to be now, but like, yeah, you really,
Soon
really,
trademark.
yeah, you really outperformed my yeah idea about what was going to happen tonight. So yeah, this is like totally epic.
Thanks.
Well done, man.
Now, tell me, did it feel like most of the good-looking stuff happened in the last 20%?
Yeah, absolutely. So if you look at making this a 15-minute stream, then you just capture the last part and enhance the speed a little bit. But for me, like the entire process, I wouldn't have want to miss like the earlier parts as well, especially the parts where you run into issues and figure the way around it, and these are the things that you run into yourself. So by having seen the design process, that really helps you and gives you the confidence of trying this yourself. So for me, like not having prepared this and running into all these issues, it feels like slacking or not performing or whatever, but actually this is what it is about. So like the entire process, I don't know about the rest of the people. There's not many people in there, but yeah, Alboro is very happy like with whatever happened on the stream and the end result. So
Thanks, Alboro.
So this is something to look back and look at the steps before this. So the end result is what will make people happy, like on Twitter with the screenshot, just like the 3D of the PCB render. But yeah, like the entire process is very helpful, especially if you're not that confident of starting doing these processes. And having people saying this is all so easy and just clicking buttons that you don't actually see what they are doing, not explaining it, yeah, not helpful for me at least.
Mm-hmm. Yeah, it's a lot of this needs to be the right dimensions and this needs to fit, and at some point you get past that and you have some time and some space to get a bit more creative and put some decoration or some fancy chamfers or fillets into it.
Yeah.
And then it starts to look good.
Yeah, but
so it's I also had at the beginning like, okay, how the heck are we going to turn this block of
we had no idea at all.
Yeah, and in the end it's
beautiful.
It becomes something.
And but also the design process and the issues that you run into because it's not symmetrical and makes you wonder more about circuit board design, especially if you're going to do this. Maybe you want to add changes to the PCB design for having it especially fit for a design in a box. But this was like a collaboration where I had like requirements and you had like ideas, and we all made this happen. And really like it. It looks so fancy. But thank you very much for being here and showing the rest of the people as well. Joseph was also saying, it was really cool to see how these things are made instead of just the end result.
Well, I'm happy to share. Thanks for hanging along.
And I think you're doing a good job. So you were already streaming. I think you should continue streaming as well. And just as Sebas is hosting the soldering streams, that whenever you run into stuff or are building stuff, that's something people will want to see.
Okay. Yeah, I was a little bit scared of doing this because it's a very long process,
Yeah.
relatively, and it's not very spectacular until you get to the end and the details.
Yeah. Yeah, but it's
So
like, yeah, that's this stream is like a 3-4 hour stream that is fit for these kind of processes.
yeah, I mean, I have, if you would ask me like 2 years ago, this would have taken me a whole day.
Yeah.
So, um, and that's also because I was too lazy to watch tutorials and just wanted to do everything myself.
Yeah.
But
Your bets.
it's still,
Yeah.
it is something you can get started with, and in the beginning it will be a lot of struggles and a lot of okay, how the heck am I going to do this? But in the end, you will learn to break down everything you do into smaller steps.
Yeah.
And if you can figure that out, then you can make just about anything.
Yeah. Yeah, I started my career working in an architect agency, and we had these Apple II computers where we did our stuff, and we created like an entire repository with all models, so you could like reuse different stuff. So if you had this special setup with electricity or a special setup with a kitchen, then you could just take that out of your library and put it into your model, so you could like have some head start already. Is that something that you have as well, like a repository of things that like I already have something factory designed, or like a Grove connector, or like USB-C, or ideas on how to fit stuff?
Well, honestly, no.
Okay.
For example, when I was working on the M5 add-on, I did search for some reference models,
Yeah.
and I can see now that some exist, but I was probably just, I don't know. In the end, I designed it myself.
Yeah.
But there are, like, at least in Onshape, there are public models for this. I mean, all public documents can be searched with the search function in the assembly studio.
Cool.
And you can just search in everyone's creations, and let's see if there are Grove connectors in there.
So, is there like other stuff that you can import, like in Visio, where you have like network diagrams, or?
Oh, look, mine is in there.
Well done.
So-
Compliment achieved.
So yeah, you can just search for existing parts,
And they even have growth models, obviously.
and if they do now.
Yeah, they do now.
And if you have your own documents with your own custom models, you can also insert those.
Yeah.
I've a while ago I designed this this ring for my sister. You've designed it so you can insert it in any assembly, in any document you want.
Yeah. Yeah, it's really
So-
look fancy, like the model's shape, and yeah. Job well done. The ring,
Thanks.
yeah, as well.
Yeah, it's as soon as I get my hands on that SLA printer, I'm probably going to produce it one more time, because it was meant as a seal
Stamping,
ring,
yeah. See.
but it broke after like half a use.
Yeah.
So
So that's because PLA, or
because PLA, and also
Okay.
crappy PLA.
okay. You can also print in metal.
Yeah, I considered that, but it cost money, and it
Yeah,
was just
true.
a hobby project at the time,
Yeah.
and I didn't even know if it would fit. So
I attended Locom, and there was someone that had his man cave, and the door came with like this Playboy key, like the special model hard sign key, and was like a very heavy key, and the key fell on the ground and it broke. So he used like 3D software to create it. So first created plastic models, and then he asked for having it printed at some metal printing companies, and they refuse to print keys, or they do not respond. And in the end, he ended up like with one that allowed him to print the key if he could prove that he was the owner of the lock, and then the other one that did not reply actually printed the key and sent it to him.
Okay.
So you could print metal, and I think it was not even that expensive, but still, for keys it will be harder. For rings it might be easier.
Yeah, it's not a complicated model in the sense that it doesn't have hollow parts.
Yeah.
So it should be printable with, for example, laser sintering or something like that.
Or make a mold.
I have not ever printed anything in metal or had anything printed in metal, so it would be a nice experiment.
Yeah.
I'll ping my sister to see if she has interest in in a metal.
Please do
example.
share your process, because we like to see that.
I will.
Cool. It was 3 hours just a few minutes ago, and it's now almost 4 hours. So time flies when you're having fun.
Mm-hmm.
Thank you very, very, very much for joining and being a co-host, and gladly have you again once more if you want to show stuff.
Sure.
Yeah, continue streaming for yourself as well, because you do well. You have a good voice. You're able to explain. Very good. So
Thanks.
Thank you very much. I will head off, not to Remoticon. I will get a few hours of sleep and then host my hardware hacking workshop, and then probably sleep for the rest of the day.
Is the hardware hacking workshop also on Remoticon?
No, the hardware hacking workshop is besides Islamabad in Pakistan. So different time zone. I think they will even stream it online. At least I saw some stuff dropping by, but it's like in the middle of the night. So.
Okay. Can you send a link, or are you going to post it on Twitter?
If there's a link, I will definitely retweet it.
Cool.
Okay. Thank you very much. Thanks all for watching. We're closing the stream now, heading to bed, and suggest you to do the same thing, unless you want to party. Next week, Tom Clement, Mr. Camzone, will be joining the stream, and looking forward to whatever he has to tell us. And thank you all. Have a nice weekend. Bye bye.
Good night.